Hey guys, welcome to the Chapter 11 test review. Thank you so much for watching this video. Hopefully it will help you get ready for the test soon. Alright, let's get going. The axis of symmetry of a parabola is x equals 3, and one point on the parabola is 5, 2. What is another point on the parabola? Remember what it means to be the axis of symmetry. It means you are in the exact middle of the graph. So if I have one point on the parabola at 5, 2, then I can figure out by how far this x value is from 3, another point that would be on the other side of it. So let me draw a graph and show you what I mean. So here's my parabola. It could be a happy or a sad parabola. And here's my axis of symmetry. So let's say this point right here, we don't know what it is. We just know the axis of symmetry is x equals 3. And then you have a random point over here at 5, 2. So here is 5, 2. What they're wanting to know is what is the point over here that is symmetric to 5 over 2? Well, we know it's going to be something over, or not over 2, sorry, something 2. And what we need to do is figure out how far the distance is. That's how we do it. So how far is 5 from 3? Well, you would do 5 minus 3, and that would give us 2. So we know he's 2 units from him, which means that this guy is going to be 2 units, but in the other way. So then we would take our axis of symmetry and do 3 minus 2, and we know that answer is now 1. So another point that is symmetric, or that is on this parabola, would be 1, 2. What is the y-intercept of the function f of x equals 7x squared minus 3x plus 1? Okay, so y-intercept. We know a y-intercept is going to be of the form 0, number, because that's what it means to be a y-intercept. You can plug x equals 0 in everywhere that you see an x, and then whatever's left over is your y-intercept. Except for that this function is in standard form. And anytime something is in standard form, then you know your y-intercept is simply going to be 0, c. In our standard form, c is the very last number. So we've got a positive 1 there. So I know my y-intercept for this function is 0, positive 1, or 0, 1. But just in case you forget that, you can go and use this method. Plug in a 0 everywhere you see an x. So 7 parentheses 0 squared minus 3 parentheses 0 plus 1. What's going to happen here is that this term is going to cancel, this term is going to cancel, and the only thing we're going to be left with is that positive 1. Hence, our y-intercept being 0, 1. Two symmetric points on a parabola are 6, -5 and 10, -5. What is the parabola's axis of symmetry? Remember, the axis of symmetry is the line that is perfectly in the middle of these two symmetric points. I know they're symmetric because their y values are the same. So if I want to find the exact middle of these 2 points, all I need to do is find the average of my x's. So average the x's, and that would be your axis of symmetry. All right, so how do we find the average of something? You find the average by adding them together and dividing by 2. So my x's are 6 and 10. So 6 plus 10 divided by 2, that's 16 divided by 2, which is equal to 8. So my axis of symmetry would be x equals 8. What is the range of the function represented by the graph? So let me zoom in on this a little bit. So on this one, they want to know the range, and your range are all of your y values. So that's all y values that satisfy this graph. Remember, your domain for all parabolas that are written, not in like a context, like a word problem, but for all basic parabolas, it is always all real numbers. And we can write that using negative infinity to infinity. That means all real numbers. So for our range, it's all of our y values. So our y values are these that run here. So starting down below, remember I said to start from the bottom and go up, we hit the arrows first. We hit the bottoms of these because technically there are arrows, right, on the end of that graph. So we hit the arrows first. So if we're talking about range, we hit negative infinity first. And then if we keep going up, and then all of a sudden we get to that top part. We actually have a stopping point here. So we got to go over to our y-axis because that's what a range is, or the y's. And we can see that 3 is the highest that this graph is going to be. It's not going to get any higher. So these values go from negative infinity to 3, and 3 is included, and that's why we do the block on the end of the 3 and not a parenthesis. Another thing you could say are all values, or all real numbers, less than negative 3. Oh, not negative 3. Sorry. Less than 3. That's another way of saying it. Okay. Moving on. How does this equation compare to the graph of g of x equals x squared? So we've got this equation. How does it compare to here? Well, we've got 1, 2, 3 transformations. Let's see if we can go through and list them all. First transformation that we can see right off the bat is we've got a positive 2 tucked in there with x. So a positive 2 tucked in the parentheses with x is going to be a shift left or a shift right, all based upon that sign. Because it's positive, we know this is a shift left. 2. And then now look at that end, we've got a minus 6, and see how he's on the outside. This number pushes the graph down. So that's going to be our second transformation, and it is a shift down 6. And then the last thing that's different between these two is the negative sign in front. The negative is going to make it a sad parabola, and it is known as a reflection. So because it goes from, this is a happy parabola, now he's a sad parabola, think about it graphically. It would have been up here, now he's down here. Remember, that is considered a vertical reflection, is how they refer to it. So vertical reflection would be another transformation between the two. So you can say vertical reflection. Another one you can say is it reflect about y equals 0, or they could have also said the x-axis. So remember, there's all sorts of different ways to say that problem. What are the x-intercepts of the function f of x equals negative 2x squared minus 14x minus 12? Okay, look at our leading coefficient of negative 2, and each term has a negative 2 in common with it. So we're going to go ahead and factor out that negative 2 first and foremost. So remember, when we factor out a negative 2, we're going through each one of these and dividing each one of them by negative 2. So negative 2 is on the outside. Negative 2x squared divided by negative 2 is just x squared. Sorry. And then we've got negative 14x divided by negative 2. That's going to be positive 7x. And then last but not least, you have negative 12 divided by negative 2, and that's going to be a positive 6. So now what we have to do, oh, sorry, I should have said from the very beginning, to be able to find the x-intercepts, we need to be able to get this in factored form and then look at the zeros of the function. That's one way to be able to do it. So the other way is to enter this function into your calculator and find where the zeros are. Because remember, an x-intercept is number, comma, 0. So I can't simply just take this 0 and plug it in here because that's not where it goes. He goes into the f of x spot and not into the x spot. So one way of doing it is you could just go to your table, enter that function in, and then look for y to equal 0. And there most likely will be 2 of them because it's a squared. There could just be 1, but for the most part, there'll probably be 2. Or you can write it in factored form, which is what I'm doing over here. So this is the factor form way. Okay, so now I have negative 2 on the outside, and now I need to do what multiplies to 6 and adds to 7. So I got to think of two numbers that when I multiply them together, they multiply to 6, but at the same time they add to 7. So I've got 1, 6, 2, and 3. Well, if I add 1 and 6, there's my answer. I get 7, because if I add 2 and 3, I get 5, and 5 does not equal 7. So my two numbers are 1 and 6. So I'm going to rewrite this as negative 2, x plus 1, x plus 6. And so my zeros are going to be simply just taking these two parentheses and setting them equal to 0. X plus 1 equals 0, so I have to subtract 1 from both sides. X equals negative 1. This one, x plus 6 equals 0. Subtract 6 from both sides. X equals negative 6. So my x-intercepts are negative 1, 0 and negative 6, 0. Write a function that represents a parabola that opens downward. So you know, because it opens downward, a has to equal a negative number, and intersects the x-axis at 7, 0 and negative 2, 0. Okay, so all we have to do is write a function. So let's just go ahead and write it in factored form since they gave us the zeros. So factored form means a and then x minus a 0 and then x minus another 0. That's factored form. And remember, it's going to be the opposite when you put it in here because of this negative sign that you see right here. When I put in this positive 7 into here, he turns to a negative 7 because of the negative sign. But when I put in a negative 2 into here, he turns into a positive 2 because of the negative sign. So all we have to do is give a negative number, any negative number whatsoever, and then our answer will be complete. So f of x, let's go with negative 2, x minus 7, and then x plus 2. Did everybody see where that came from? This was an x minus a positive 7, and this was an x minus a negative 2. And that's why it changed to positive 2. How do you determine from a table if a function is a linear function? What we're looking for here are the first differences. We did an example in there where we had a table. Let's say it was negative 2, negative 1, 0, 1, 2. And then I had 7, 5, 3, 1, and then negative 1. Something along the lines of that. Now what we do for first differences is we go 5 minus 7. So 5 minus 7 is negative 2. And then 3 minus 5 is also negative 2. 1 minus 3 is negative 2, and negative 1 minus 1 is also negative 2. Now, if we were going to go and do another set of differences, the second differences, then you can see that all of these would have been 0. So what is a first difference? A first difference is when you subtract two consecutive y values and you get a constant number. That means it is linear. If you do a second difference, then you would get 0. So that's how you determine from a table if a function is linear or not. If a function was quadratic, remember quadratic, you have to go all the way to the second difference before you get a constant. How is this graph different from a graph of the of the function f of x equals x squared? Well, it's been moved. F of x equals x squared is a graph that sits right here. So it has definitely moved. It first of all has flipped, so we have to put the fact that it has a negative sign in front of it. So f of x equals now a negative sign. And then what he's also done is he's shifted over to the left 1, 2, 3 units. He's gone 3 to the left. Well, how can I write 3 to the left into an actual function? So what I'm doing right now is I'm writing this in vertex form. And think about vertex form. Vertex form is f of x equals a x minus h squared plus k, where h, k are your vertex. Well, here's my vertex right here. That's -3, 4. So I could simply just go in and put in -3, 4. Your A value didn't change. This is the same size graph. So that's why it stays 1. It's just a -1 because it flipped over. So then it would be x minus a -3, or like I always say, when it goes into there, it switches signs, squared, and then plus 4. And so was that answering the question? How is this graph different from a graph of the function f of x equals x squared? Well, it was shifted 3 to the left, and then we shifted it 4 up, and then we did a vertical reflection. Sorry, I kind of ran out of room there. So vertical reflection. All right, that was it for that one. What is the vertex of the following equation written in vertex form? So here we've got the equation 6 parentheses x plus 7 squared minus 3. Remember, vertex form is f of x equals a x minus h squared plus k. And this is my vertex. This is the x-coordinate of my vertex, and this is the y-coordinate of my vertex. And the thing you have to think about is you've got to switch the sign when we're dealing with anything that's tucked in with x. Okay, so what is our vertex? Our vertex is going to be -7, -3. What is the vertex of the parabola f of x equals x squared minus 4x minus 8 that has an axis of symmetry of x equals 2? Okay, there's one thing else you got to remember about that vertex. The axis of symmetry goes through the vertex. It actually cuts him right in half. So it goes through the vertex. So right now, since they gave us this axis of symmetry, they gave us the first number of the vertex. All I'm missing is the y value. So they gave me the x, I needed the y. All you need to do is take your x and plug it into the equation. So I would get f of 2 equals 2 squared minus 4 times 2 minus 8. 2 squared is 4. Minus 4 times 2, which is -8, minus 8 again. 4 minus 8 is -4. -4 minus 8 is -12. So my vertex for this problem would be 2, -12. What is the axis of symmetry for a parabola with x-intercepts -5, 0, and 13, 0? Remember, the axis of symmetry cuts right in the middle of these guys, so all we have to do is, again, find that average. -5 plus 13 over 2. -5 plus 13 is 8. 8 divided by 2 is 4. So our axis of symmetry, remember, it's so very important that you put x equals, so x equals 4. Write a function that represents a parabola that opens downward. So a's got to be a negative number. And then has a vertex at -2, 5. So we're going to go with vertex form. Vertex form is x minus h squared plus k. A's got to be a negative number, so pick any negative number. -4 sounds good. X, and then I see a -2, so it's going to go in as a +2 squared. And I see a +5, and it also goes in as a +5. So there's our answer. Write a function that represents a parabola that is translated 5 units to the left and 10 units up from this function right here. So I've got f of x equals, I'm going to go ahead and write it in vertex form because that's the easiest way to be able to do it. X 5 units to the left. Well, left you would normally think is negative, but in this case, remember, we've got to put that plus sign. So x plus 5 quantity squared, and then 10 units up would be another 10, but it's positive on the outside. What is the vertex of a parabola represented by the equation -9 and then x minus 6 squared minus 2? So they want to know the vertex. Remember, with vertex form, it's your h comma k that is your vertex. So f of x equals a x minus h squared plus k. That's what form this is in. So our h is -6, but when we put him into the parentheses, into the vertex part, you got to drop that negative sign. and our k is -2, and you put it in exactly like you see it. So our vertex for that form, or for that function, is 6, -2. Which of the quadratic functions has the narrowest, skinniest graph? Remember, we talked about this in class, the skinniest graph. That's the people who go and work out a whole lot more than the rest of them. And so this person right here goes to the gym 3 days, this one goes 2 days, this one goes 1 every 5 days, and this one goes 1 every 8 days. So think about these two guys. These are going to be your, wider graphs because they don't go and work out enough. And these are going to be your skinny or your narrow graphs. And which one between the two of them would be skinnier? Well, this one. So the trick is the bigger A is, bigger A is, the skinnier the graph is. So between the two, y equals -3x squared would be the narrowest out of all the graphs. Which of the quadratic functions has the widest graph? So that's going to be a fraction, but it's going to be the fraction with the biggest number on the bottom. So between these two, this person only goes 1 out of every 12 days. This person goes 1 out of every 3. So this one actually works out way far less than the rest of them. So he's going to be the widest graph right here. The narrowest one was this one, but the widest one is 1 over 12. Write the function x squared minus 12x plus 27 in factored form. So we got to do what two numbers multiplies to a positive 27 but adds to a -12. So think about 27, all of the multiples to it. It's got to multiply to a positive, 1, 27, 3, and 9, and those are it. So it's 3 and 9 that definitely add to 12, but notice this is a -12. So because it's a -12, but it multiplies to a positive, you know both signs are going to be negative. So it's a -3, -9. So writing it in factored form, h of x equals x minus 3, and then x minus 9. For the function f of x equals -5, x plus 8, x minus 2, determine the way the parabola opens and the x-intercepts. Remember, the number in the front determines whether he opens up or down. He's negative, so this is going to open down. And he's in factored form, so we can find out those x-intercepts. It's the opposite of what we see in here. So I see a positive 8 and a -2. So my x-intercepts are going to be a -8 and a +2. And we got to put those zeros in there, so represent that as an x-intercept. For the function f of x equals -6, x plus 2 squared minus 1, determine the way the parabola opens and the vertex. Well, the number in the very front tells me that he opens down. The +2 tells me my beginning vertex number is -2, and the -1 tells me my last one is -1. Remember, this is in vertex form, so we can look at it right away and be able to determine the vertex. For the function f of x equals 2x squared minus 9x minus 5, determine the way the parabola opens and the y-intercept. This is in standard form, so I know that the y-intercept is just going to be 0, c, and in this case, that's going to be 0, -5, because there's my c right there. But just in case you forget that, remember, all you have to do to find the y-intercept is plug in a 0. So I get 2 parentheses 0 squared minus 9 times 0 minus 5. See how that still equals a -5? So that's why that's our y-intercept. Oh, and the way it opens up, sorry, your A is positive in the very front, so he's going to open up. The happy parabola. Use the graph to identify the properties listed for the function x squared plus 2x minus 3. So they want the domain. Remember, your domain is always going to be -infinity to infinity, or you could write all real numbers. -infinity to infinity. And now let's look at our range. So the range are all of my y values. You can see if I start from the bottom and work my way up, the first thing I hit is -4. So that's why I put a -4 right into there. And then keep going all the way up. The next thing I hit are the arrows. So he's going from -4 to infinity. Or you could say all real numbers greater than or equal to 4. All right, the zeros of this function, this is where it crosses the x-axis. So we've got a positive 1 and a negative 3. Those are my zeros. So positive 1 and negative 3, and go ahead and put those with y being 0 because those are my x zeros. Interval of increase. So interval of increase is when the graph is going up. Remember, we read graphs from left to right. Right here, the graph is decreasing, so it's definitely not increasing. And that went from negative infinity to negative 1. Remember, whenever we read left to right. We use our left to right numbers. You do not use the up and down, you use left to right. So our interval of decrease is negative infinity to negative 1. Sorry, you do parentheses around intervals of increase or decrease. And their interval of increase is when it starts going back up again, and that's at negative 1 to positive infinity. So negative 1, positive infinity. All right, guys, I hope this helped you out a lot. I hope we do fantastic on the test that's coming up soon in class. Thanks for watching. Bye-bye.